Good morning, ladies and gentlemen. On behalf of the Mitsubishi Heavy Industries Group, I'm pleased to welcome you to our event on accelerating the energy transition for net zero cities. My name is Jay Wadhwani, Chief Operating Officer at MHI Asia Pacific. Today, I want to focus on how improving infrastructure will create sustainable cities. First, the challenge of rising global temperatures. When Singapore gained independence in 1965, the average annual temperature of Singapore was 26.6 degrees Celsius. Last year, the average was 27.9 degrees Celsius. You may say that the difference is just over 1 degree, but a permanent rise of even a single degree leaves a deep impact on the environment and urban livability. The picture is more dire if you go back further in history to compare. Modern Singapore, being a city-state, is heating up faster than the global average. Local temperatures are 1.8 degrees Celsius higher than they were in 1948, according to data from Singapore's Meteorological Service. In contrast, global temperatures have risen at a much slower rate since pre-industrial times. In the face of this threat, the world has pledged to work together to limit that change in global surface temperatures to well below 2 degrees Celsius, below 1.5 degrees if at all possible. The stakes are high. According to UN Habitat, cities consume 78% of the world's energy and produce more than 60% of greenhouse gas emissions. Yet, they account for less than 2% of the Earth's surface. Therefore, it is imperative that we implement solutions to reduce emissions and lower the energy requirements of the cities where we live and work. District cooling is one such solution. For large commercial complexes, using centralized production of chilled water will reduce energy consumption and emissions. Besides energy, this also saves money in the long run. Our conference venue today, the Sands Expo, uses district cooling. And MHI has had a part in this incredible project. 2 decades ago, MHI was first engaged to provide 5 chillers with a total cooling capacity of more than 10,000 tons for offices in this area. In phases since then, we have installed a total of 14 of the plant's chillers. The plant provides air conditioning for the whole Marina Bay area, including the resort facilities and business center. Besides district cooling, we must look at the transportation sector alongside the rise of urban cities and megacities. Low-carbon solutions, such as automated guideway transit systems called AGTs, which can transport many people efficiently, are extremely useful. These AGTs involve driverless vehicles traveling on a fixed track, such as the Sengkang Punggol LRT system in Singapore. This is a project I know well. MHI has supplied more than 50 cars for the system since it began in 1998. Our AGT systems feature in urban transportation solutions all around the world, from Singapore to Macau, Japan to Orlando, and many more locations. AGTs include a range of systems such as the Automated People Mover, or APM system. APM systems have been used in airports globally. In Southeast Asia, you can see APM systems at airports in Indonesia, Malaysia, Thailand, and Singapore. The SkyTrain APM system at Singapore's Changi Airport connects 3 terminals over more than 6 kilometers. We were originally commissioned to build the APM system at the airport in 2002 and have operated and performed maintenance there since operations started in 2007. Moving to another solution, cities are also combating mountains of waste, which can pollute as well as consume valuable resources such as land for disposal. According to the World Bank, there are 2 billion tons of municipal solid waste generated annually across the globe, with at least 33% not managed in an environmentally safe manner. In Asia, rapid urbanization and industrialization has led to rapidly growing mountains of waste. As incomes rise, so does waste. There is a need for greater proactive waste management. Waste-to-energy solutions can help here. They can lower emissions by using waste as biomass for power generation. This solves 2 challenges at once: less waste buried in landfills, and the waste is converted to energy. Finally, cities can mitigate urban heat and lower emissions to remain livable and sustainable through decarbonization of existing infrastructure. This is especially true for power generation. This involves using innovative technology such as advanced gas turbines, carbon capture, utilization and storage, and co-firing gas turbines with cleaner fuels like hydrogen and ammonia. We simply cannot tear down today's power plants and build new ones in their place, nor do we want to. Certainly, there will be some new plants built, while a few older ones approaching the end of their lifespan will be mothballed. But that leaves a vast majority of plants that need solutions to reduce their emissions today and in the years ahead. A key strategy could be to upgrade gas-powered plants with turbines that can co-fire hydrogen. For example, Mitsubishi Power, together with Georgia Power and the Electric Power Research Institute, has successfully validated fuel blending of hydrogen and natural gas at both partial and full load at Plant McDonough Atkinson in Georgia. The demonstration project was the first to validate 20% hydrogen fuel blending on an advanced class gas turbine in North America, and the largest test of this kind to date, with 20% blend providing approximately 7% reduction in carbon emissions compared to natural gas. The various solutions I touched on today are simply parts of the puzzle that many nations are trying to solve. How do we get to net zero? Urbanization and growing cities complicate that goal, but it doesn't make it impossible. It will take a joint effort by all parties and different strategies, including infrastructure development, coming together to create sustainable and livable cities. At MHI Group, we believe that our goal to accomplish carbon neutrality by 2040 is indeed achievable. With continuous innovation and implementation, we will meet our objective, and we hope to help cities meet their goals too. In closing, I wish to express my sincere hope that all of us at this conference, which brings together respected delegates and speakers from so many different cities, will have an opportunity to discover innovative solutions for sustainable cities. It will not be a one-size-fits-all for such a diverse mix, but rather finding solutions that best fit a city's requirements, resources, and national policy goals. Thank you all for your time today.
Jay, thank you very much for the keynote. Energy systems have a fundamental role in accelerating decarbonization, and this is not surprising, considering that 90% of the global population is connected to the electricity grid, and global energy system is still highly carbon intensive. Today, 55% of the world population lives in city, and we expect this to continue to grow. 7 in 10 people will live in cities by the year 2050. In a climate-challenged world, cities do play a very crucial role to catalyze the transition to net zero. Therefore, the topic today, accelerating the energy transition to net zero cities, is an important one to discuss. We have a panel here today to talk this topic, and let's start with an introduction. We'll start with you, Jay.
Thank you, Sweetchen. My name is Jay Wadhwani. I'm the Chief Operating Officer for Mitsubishi Heavy Industries, Asia Pacific. I'm based right here in Singapore.
My name is Lynette Chia. I am an Associate Professor of Engineering Systems from the Singapore University of Technology and Design. My area of research is in sustainable mobility.
My name is Teppei Takahashi, Senior Vice President of Mitsubishi Heavy Industries Asia Pacific, in charge of business development.
Thank you. That's a short and sweet introduction. Let's get straight to the topic, and I will start first with you, Takahashi-san, and let's talk about sustainable power generation. We know that energy is a major factor for cities as it considers its decarbonization strategies. And hydrogen has been emerging actually as a key fuel in that transition. And many are talking about hydrogen-produced renewable energy. Let's start first with the first question. Would it be better to just simply use renewable energy rather than hydrogen-fueled power?
Thank you for your question. Countries continue to develop renewable energies such as solar or wind,
Yes.
and connect them directly to grid. However, there's a need to utilize hydrogen. And first, renewable energy produce intermittent power that requires some backup energy facilities, such as battery energy storage system or thermal power generation system. Renewable energy can be utilized to produce green hydrogen. Then we transport it and store it and combust it in existing gas turbine combined cycle plant. That is commonly used thermal power plant. And by doing that, we can cover the intermittency of renewable power.
That's a good point. Intermittency and intensity as well has always been the issue with renewable energy.
Yes.
Can you then talk about what are some of the major challenges in commercializing hydrogen? And Takashi-san, if you could also please describe the differences between green hydrogen and blue hydrogen.
Okay, thank you for your question. Now we can mix up to 30% of hydrogen into natural gas and combust in gas turbine combined cycle. And now we are developing technologies to combust 100% hydrogen, and that technology will complete by 2025. And then the technology to combust hydrogen is almost ready, but challenges exist in supply chain. Yeah. So we have some projects to facilitate the supply chain of hydrogen. And the second question, your second question talking about the green and blue. Yes, green hydrogen is produced from renewable energy and hydrogen. And the renewable energy, using renewable energy and the electrolyzer, we produce hydrogen from water. That is a green hydrogen. And blue hydrogen is produced from natural gas. Then generate hydrogen and CO2. And CO2 will be recovered by carbon capture system. That is a blue hydrogen.
Yeah, yeah. That's all really interesting, and it's good to hear that the technology will be commercially available by the year 2025. Just give us some examples of the opportunity for emissions reduction in these particular technology. How much carbon can we reduce with a hydrogen-fueled power generation?
Let me explain by some example. In the USA, we have a project to validate 20% hydrogen mixing to natural gas on the latest model of gas turbine combined cycle plant at the Georgia Power Station. In that project, we mixed 20% hydrogen, then reduced 7% of carbon emissions compared to natural gas.
Yeah, and with the huge emissions generated from power generation, 7% can be quite significant over time. I would like to move to Jay to talk about district cooling. We do understand urban heat island effect. We talk a lot about, in fact, the news going on today is about the heat wave in Europe.
In Europe, correct.
Yeah, let's talk about, what are some of the issues that cities are facing with district cooling? And perhaps we start first with that.
Right. So let me first explain a little bit of district cooling. Okay. District cooling is basically a centralized cooling plant. So instead of having individual plants in each of these buildings, for example, we take and combine 7 to 10 or even more buildings or locations, have a central plant, which then distributes chilled water. Okay, That's basically what district cooling is. Now, the beauty about this is that the efficiency improves dramatically, almost 20 to 30% efficiency by combining these systems. So it's not really new technology. It's been around for a while. But the advantage is that it increases efficiency, reduces cost, actually frees up space in buildings too, because you no longer need the cooling towers and the chillers in that location. You basically just have piped chilled water.
Yeah.
So big advantages. Singapore is not new to district cooling, and I know district cooling is being implemented in many other cities around the world. To mention a couple here in Singapore, I think Tampines City, I think SP Power is working on that as we speak, and that system is due to be completed also by 2025. There's another one in the industrial sector in Singapore, Sungai Kadut, I believe is the name of the place, which they are talking about district cooling. So it's a terrific way, Swee Chen, of actually reducing carbon footprint by combining these systems. Now, one of the other things that, or questions I get asked are, what about brownfield? So far, we've talked about the grassroots systems, and the grassroots ones are fairly straightforward to install. Brownfield is also possible. We've done that in many locations in Japan, and there are other locations around the world, where what we do then is combine other chiller plants. So you may not have just one, but maybe 2 or 3 and no longer 10. And then engineer the piping system such that you can, in essence, turn the existing system into a district cooling system. Okay, so very useful. Technology is there right now, and I think an excellent thing for cities to implement.
What would you tell city dwellers? So you talk about the efficiencies of district cooling. What would you tell city dwellers looking to consider, is it air conditioned, is it district cooling? How would you explain the benefit of district cooling versus, say, having my own air conditioning at home with my own compressors?
So this may sound strange, but look, the bottom line is costs will come down. So city dwellers, residents, the message is that your monthly bill will actually reduce, your cooling bill. Okay, and we talk a lot about cooling over here. Actually, of course, in other countries, we also do district heating. So this includes heating and cooling systems. So bills will come down, and I think that everybody's open to that.
Yeah, I think it's music to everyone's ear, especially now with all the discussion of rising energy costs, inflation, bills coming down is music to everyone's ear. So what's stopping municipalities from installing district cooling? Okay, good question. Of course, there's got to be some initial capex cost, capital cost that you have to spend. And that is basically what may be holding back certain cities from doing it. So I think that they just need to budget for it and plan for it and look at opportunities that are very good. In other words, low-hanging fruit, where they can either combine systems or put in new systems to implement district cooling. Yeah. And I think what you're also saying is there is a role that policies must play in order to introduce technologies that are new, that are innovative to the homes of individuals in order to help the cities in a whole to reduce their carbon footprint.
That is exactly, and I know we're all for that. I mean, clearly every one of us believes that. So, okay.
Thank you, Jay. And Lynette, to you, you specialize in transport, in mobility solution. And let's just talk a little bit about this, because we have seen all over the world, transport has a high reliance on fossil fuels. So what do cities need to think about when it considers solutions in transport, in mobility?
Right. So the transport sector, is responsible for about 1/4 of the world's greenhouse gas emissions. So we're concerned about climate action and all that. I think this sector is worth targeting some of the solutions around it. I think there are, of course, many ways that cities can address the overall impact of transportation. I mean, aside from carbon emissions. There are also issues surrounding air pollution, noise pollution, congestion, and all that, if it's not managed well.
Yeah.
So I think the solutions are, there are many. The first and most obvious one would be to encourage the use of public transportation in cities in order to accommodate so many travelers and the demand that's growing for transport. I think public transportation is probably the most efficient way to move as many people as possible, while minimizing some of the effects that I spoke of. The second overall approach is to leverage on data and some of the newer intelligent transport systems that are coming out. So nowadays, many people carry mobile phones. We are able to sort of monitor and observe how people move around, preferred travel patterns, and respond to it, right? Mm-hmm. So we can leverage on that to introduce like demand management policies, or find ways where people can share rides and like be very demand responsive to what's needed on the ground. That way we can have more optimized vehicle routing or more optimized service provision to adapt to the demand. So that's another general approach. Mm-hmm. And the last, of course, everyone is trying to pursue now. Many cities are thinking about alternative fuels and technologies for our vehicles, and electrification seems to be the one that's in the lead right now. So this momentum towards electric mobility, I think, will only grow as we move forward, and then think about ways to encourage that growth, easy, make sure that it's a smooth transition away from this fossil fuel reliance that you speak of towards these alternative fuels.
Yeah. And there's always, you talked about infrastructure, there's always that chicken and egg challenge, right?
Yes.
So when you talk about use public transport has to be accessible, it has to be reliable.
Indeed, yeah.
Yeah, and so just your thoughts around what are some of the challenges, and how do we break this chicken and egg cycle when it comes to greening of cities through more, low carbon mobility solutions?
Yeah. So by infrastructure, I mean, if we're referring to electric chargers, right? Like this charging infrastructure that has to be there before.
Or even train stations,
Right,
bus stops.
Yes. I think to make public transport attractive, you have to make it the preferred mode, right? It has to be accessible, like you speak of. Travel time has to be competitive with that for private car, a comfortable ride, ideally the routes serve what we're looking for, right? So I think very careful planning does have to be there to make sure that many people, many households can reach the train station near to me or the bus stop near to me before they would consider, right? Of course, there are complementary policies to discourage car use on the other end. You can encourage public transport, discourage car use. I think they have to go together in order to achieve a city that's people move around mostly by public transport. For charging infrastructure, I think that's a very interesting one that we will be witnessing. We will see cities move away from, again, using gasoline and diesel for our cars and then turning to electric versions of our vehicles. So I think the infrastructure has to keep up with the demand, or the incentives again in place for encouraging people to switch to electric versions of their cars.
So thinking about like new ways of moving people, right? Lots of people around the cities, light rail systems.
Right.
Can you talk a little bit about that? How that helps? How can we? How does it help with energy transition to net zero?
So again, light rail is not new. Okay, it already exists in a lot of countries and cities around the world. I remember growing up in Amsterdam, we had trams. Most recent, of course, here is at Sengkang Punggol LRT. And light rail is just another mode as part of the overall infrastructure for transportation. So you still need cars, you still need buses, you need trains and other modes, and light rail is yet another mode. It runs on electricity, okay? It's driverless, so you have no one in the cab. It reduces congestion because people who would be taking buses, for example, can now take the LRT, okay? Frequency is higher because it's on a guided track. I mean, we're all following up right now in the world as to, automated driving, but that's not quite here. So these are on tracks. It's very safe, okay, because you're not going side by side with other vehicles. So there are so many advantages of having light rail. Of course, we have them in the airports, that transport people from one terminal to the other too. But the one in Sengkang Punggol, and which is now being expanded, by the way, obviously people have reacted very positively to light rail. So from that standpoint, it is truly something that I think all cities should integrate. And if they can elevate the structure like we have done over here, even better, because it indeed reduces congestion. So in a nutshell, that's kind of my take, or our take on LRT.
Yeah, yeah.
Right.
What's just if you could share, what's
Right.
MHI's role in light rail?
Okay, so MHI's role there is not only, we actually provide the cars, the rolling stock. It's called rolling stock, okay? We provide those. And then we also do the signaling system, okay? We have local contractors build the civil infrastructure over here. But other than that, all of the guts basically are provided by MHI. And then we have local operating and maintenance service also. And those contracts are typically 20 to 30-year contracts. And so the good thing is that we maintain and operate those systems. In effect, to buying a new car and getting support from your dealer, this is basically what we do in layman's speak. Okay?
Yeah.
So it's good for us as a company too, of course.
Yeah. I want to move to something completely different, which is waste.
Right.
We know waste and consumed materials are important source actually of greenhouse gas.
Yes.
And we talked a lot about net zero carbon, but we do not talk about net zero waste. And I know that you do work in waste to energy.
Right.
Can you talk to us about the opportunities there?
Yes. So let me first explain what is a waste to energy plant. Okay. The incinerator plant basically is where the waste goes, municipal waste. Okay, that you could call that garbage, trash, rubbish, whatever it is from the house. Okay, what we throw down in the chutes is collected and brought to the plant. And that incinerator plant, then the waste is burnt over there. Okay, and based on that, heat is generated. Okay, that heat then runs a turbine, which then generates electricity. So basically, it's like a mini power plant. You're taking your waste over there, burning it. Okay, now one would think, okay, then you're actually causing more fumes, but that's not true. The flue gas is actually scrubbed. Okay, scrubbing basically means removing the particulates and the bad stuff. So the flue gas that comes out is actually very clean. Okay, so that's what a waste to energy plant does. Now, having said that, I still want to highlight that recycling is an important part of all this, because the less recycling you do, the more recycling you do, the less waste you have to incinerate. And MHI has installed, I think, more than 300 plants around the world that are working very well in terms of waste management. And the last comment I would want to make also is landfills. If you've ever been around landfills, they're not so nice places to visit, and landfills take space. And cities don't have that space. I know for sure Singapore does not have that extra space. And if it did, it would rather use it for other purposes. So you would reduce landfill space by having incinerators too.
Yeah.
Okay.
I think in that short discussion about waste to energy, you brought up a few things, right? That's the role that corporations play in developing the technologies. That's the role that regulators play in terms of the regulations that will help support this technology. And then you talked about recycling. So there's a role that city dwellers, population will play in they themselves needing to play a role in contributing to net zero emissions through the way they use and the way they waste the things that they consume. We move on to innovation, and we know that both technology and policies do have starring roles to play in energy transition. And I wanted to ask first about why it's important for cities to consider the move to net zero carbon emissions. And a lot of it also has to do with sustainability, improving quality of life in cities. So perhaps any of you, if you have thoughts, to just chime in around how does making cities more sustainable improve quality of life for urban city dwellers?
One simple thing, noise pollution that we normally don't talk about, okay, would be greatly reduced also when we go to EVs and other things. I often sit at my house and the buses go by sometimes very, very loud. So noise pollution, I think, would help a reduction rather in quality of life. I mean, the air that we breathe because of internal combustion, for example, I think that's a significant step change in terms. That's just one of my opinions.
Yeah. I agree. Yeah. I agree with Jay. I think there are a lot of co-benefits that we can think of when we pursue this net zero goals and all. So sustainability as a whole, also thinks about things like biodiversity and things that we can improve with more natural spaces. That helps with mental health. If we were to reduce noise pollution, I think it helps also with overall public health. So I think considering these other benefits is always.
Yeah. Takashi-san, do you have any thoughts?
Yeah, I agree with you both. Yes.
Mm-hmm. Yeah. And Lynette, I wanted to ask you, right? So in cities, we talk about innovation, and just going back to what you were talking about in EVs, what are some of the new ideas, the interesting ideas that is happening in research, say in the university that you're from?
Yeah, so in terms of transportation, innovation has a very big role to play. Actually, it's a very exciting sector. We see a lot of good ideas and business ideas coming out all the time. So when I teach transportation, I always have to refresh my material to keep up with all the interesting ideas. I think there's a concept of like shared mobility, right? Where I think we've seen that coming in. I mean, it's not just so clear as in not just a transport mode, but the way we use these modes that matter. So shared mobility is coming, and we see these shared bicycles, shared scooters, carpooling. All that tries to make use of the capacity as sufficiently as we can before we need to introduce even more vehicles on the roads. There's also an idea of like sharing capacity across not just passenger transport, but with freight transport as well. So now we see a lot of goods deliveries happening. Over the pandemic, everyone turning to online shopping instead of making personal trips, right? So there's, again, lots of opportunities there to leverage on the same capacity or infrastructure, and then sharing ways to make use of what we already have.
Yeah. That's interesting. So far what we've talked about, there's technology, there's policies, there's also consumer behaviors. That's this willingness to share, right? Would you open you're driving a car, would you allow strangers in your car who happen to go on the same route? So what we're talking about is energy transition, goes beyond technology, goes beyond policies. It also requires changes in behaviors of city dwellers as well. And I want to close that with just getting your thoughts on one thing. So what we've talked about is the race to net zero is a team sport. Everyone needs to play a role. There are different skill sets that are required in getting us to that outcome of a below 2-degree world. So can you just share your thoughts around what roles can say each of you in a capacity as representing your corporations or individuals, what roles can you play in contributing to net zero?
From MHI standpoint, look, we need to continue to innovate, okay? Our R&D centers need to continue to be working full speed ahead, okay, to find solutions, to take a look at existing things and make them better also. And we are indeed doing that. So Certainly from a corporation standpoint, MHI clearly recognizes this role, and we signed up for carbon neutrality by 2040, and we genuinely believe that. And so as a company, that is our target, and we'll do everything possible to innovate, come up with ideas that we can then spread around the world to improve the quality of life.
Yeah.
Okay?
Thank you. Lynette?
Yes, I agree with Jay, and I really like the expression team sport, because it's indeed, not just governments, corporations, households, communities, individuals, all have a part, right? For students, since I work with students a lot, I think we can empower ourselves with new knowledge about sustainability, what it means, and then share that alongside with whatever careers they end up in, right? To always keep that perspective in mind as they move forward.
Takahashi-san, what about you? What role can MHI play in this energy transition to net zero?
Yes. MHI's origin is manufacturing
Yes.
and engineering, and we have a very strong presence in that area. But to achieve net zero, to create hydrogen society, we have to how can I say, create some ecosystem of hydrogen.
Yeah.
Gather some companies and make together the hydrogen society. Yeah, that is our mission.
Yeah. And that's a perfect example, isn't it, for a solution that really require many players to play a role. And it's good to see MHI playing a leadership role here in corralling all the different players in order to solve the supply chain problem for I should call it challenges for hydrogen.
Yes.
Well, thank you very much to fellow panels. It's been a very good discussion to a very important topic, the energy transition for cities to net zero emissions, and a lot of ideas and solutions being discussed. And the main point here is many of the solutions have already been available. And what it takes is whether be it investments, government policies, people playing their respective role, and importantly, corporations playing roles in bringing these technologies together in order to deliver viable solutions for city dwellers, for dwellers beyond cities, and also for nations to contribute to their pledges for net zero emissions. Thank you all very much for the discussion.
Thank you.
Thank you, Suji. Thank you.